Hello everyone, myself Sagar Gunani from Elite Careers and this video lecture is on mixture and irrigation part 3. Let's start with few problems related to it. Question 11. In 1 kg mixture of sand and iron, 23% is iron. How much sand should be added so that the proportion of iron become 13%? In this case, initially iron was 23% and remaining percentage was sand. However, certain quantity of sand is added to the mixture so that the proportion of iron will becomes 13%. So let's look at the solution over here. So initially the amount of iron in the mixture is 23% in 1 kg mixture. So 23% of 1000 is nothing but 230 gram. So 230 gram is of iron and remaining is of sand. So sand is equal to 770 gram. Now let's say that x kg of sand is added to the mixture such a way that the proportion of iron becomes 13%. So in a new mixture, if iron is 13%, then remaining will be sand and sand will be 100 minus 13, which is nothing but 87%. So the new ratio over here becomes 230 is the initial weight of iron upon 770 gram was the initial weight of sand, and in that 770 gram x quantity is added. Now if we add this x quantity, the ratio becomes 13% iron upon 87% of sand. So this is our new ratio. From this new ratio we can find out the quantity of x. So solving this equation, we can find out the value of x, and x turns out to be 769.2 grams. So adding this quantity of sand, you will get iron as 13% and sand as 87%. So in such kind of a problem, initially we need to find out the quantity of sand and iron. Once the quantity of sand and iron is known, then x quantity of sand has to be added so as to get the new ratio of iron and sand. And comparing this ratio, we can find out the value of x grams. Now next problem. Question number 12. In a particular type of alloy, the ratio of iron and carbon is 2:3. The amount of iron that should be added to 15 kg of this material so as to make the ratio of contain 1:1. Now initially there is an alloy of iron and carbon having a ratio of 2:3. Now we need to add iron in such a way that the ratio of iron to carbon becomes 1:1. Now the amount of alloy initially is 15 kg. So in this 15 kg, first of all we will find how much is the iron and how much is the carbon. So let's say that iron is to carbon is 2:3 and we have a 15 kg of this alloy. So in this 15 kg, the amount of iron will be 2 by 5 into 15, which is equal to 6 kg. And the amount of carbon in this 15 kg of alloy will be 3 by 5 of 15, which is equal to 9 kg. Now we need to add x quantity of iron in such a way that new ratio becomes 1:1. So let's say that initially the quantity of iron is 6 kg. In this 6 kg of iron, x quantity of iron is added and the amount of carbon is same, then the new ratio becomes 1:1. So this is equal to 1:1. So but obvious that x will be equal to 3 kg. So when the x will be equal to 3 kg, that is when 3 kg iron is added, then the amount of iron will be 9 kg and the amount of carbon will also becomes 9 kg and the ratio will be 1:1. So the answer over here is, in order to get the ratio as 1:1, the amount of iron which has to be added is equal to 3 kg. Next problem, question 13. 6 kg sugar costing rupees 10 per kg is mixed with 4 kg sugar costing rupees 15 per kg. What is the average cost of mixture per kilogram? Now we have two quantities of sugars and those two quantities are having different price. So first quantity is 6 kg and it is at 10 rupees per kg. So if it is 6 kg, then for 6 kg the amount will be 10 into 6, which is nothing but 60 rupees. Same way for 4 kg sugar the amount is 15 rupees per kg. So 15 into 4 will be 60 rupees. So you can say that for 6 quantity sugar, 6 kg sugar, and the price is 10 rupees per kg. So the total cost is rupees 60. And another quantity of sugar is 4 kg at 15 rupees per kg. So the total cost is rupees 60. Now overall cost of this mixture, the mixture will be of 6 kg plus 4 kg, which is equal to 10 kg. So the total cost of 10 kg of sugar will be 60 plus 60, which is equal to 120 rupees. Now if 10 kg of mixture is having a cost of 120 rupees, then 1 kg will be equal to 120 by 10, which is equal to 12 rupees per kg. So the cost of the mixture per kilogram is 12 rupees per kg. Next problem, question number 14. A mixture of wine and water contains 80% wine. In a 50 liter of such mixture, how many liters of water are required so as to increase the percentage of water to 50%? So initially, in a wine, 80% was wine and 20% was water. Now, 50 liter of such mixture is there. Then in this mixture, how many liters of water has to be added so as to increase the percentage of water to 50%? Okay, so in this 50 liter of mixture, 80% was wine. So first of all, we will find out the amount of wine and the amount of water in the mixture. So in the 50 liter, 80% is wine. So 50 into 80 by 100, which is equal to 40 liter. So the amount of wine in the mixture is 40 liter. And the amount of water in the mixture will be 50 minus 40, which is equal to 10 liters. Now, in this case, we have to add water to the mixture such a way that the percentage of water is 50%. So if the percentage of water is 50%, then the percentage of wine will be also 50%, right? So in a new mixture, the ratio of wine is to water will be 50% by 50%, which is nothing but 1:1. 1:1 means what? There is an equal quantity of wine and the water in the new mixture. So in order to get equal quantity of wine and water in the new mixture, if initially the quantity of wine is 40 liter and we only have to add water in the mixture, and the water initially is 10 liter. So but obvious that in order to get equal quantity of wine and water, we need to add 30 liters of water in the mixture. So the answer over here is 30 liters. So you can say that initially we have 40 liters of wine and 10 liters of water, and we require 50% wine and 50% water in the mixture. So we have to have 40 liters of water, which is equal to the amount of pure wine, which is constant, and it is available in the mixture. Thus we have to add 30 liters of water in the mixture so as to get 40 liters of water and 40 liters of wine. That is 50% of wine and 50% water. Understood. Now let's move to next problem. Question number 15. There are two mixture of honey and water in which the ratio of honey and water is 1:3 and 3:1 respectively. The 2 liters are drawn from the first mixture and 3 liters from the second mixture, and it is mixed to form the another mixture. What is the ratio of honey and water in it? So in this case we have a two mixture. In first mixture we have honey is to water in 1:3. In the second mixture we have honey is to water in the ratio 3:1. Now 2 liters from the first mixture and the 3 liters from the second mixture is drawn so as to form the mixture from these two vessels, right? So this mixture of 2 liter from the first and 3 liter from the second will be equal to the 5 liter, and in this 5 liter we need to find out what is the quantity of honey and water, that is what is the ratio of honey is to water in the mixture of which is obtained by adding 2 liter of first and the 3 liter of second. Understood? So honey is to water in the mixture we need to find out. Now in this 2 liter of the first mixture, honey is 1:3. So the amount of honey in this 2 liter will be 1 by 1 plus 3, that is 1 by 4 of the 2 liter. Understood? Also we have 3 liters of the second mixture. In the 3 liters of the second mixture, the amount of honey will be 3 by 3 plus 1, that is 3 by 4 of the 3 liter. So the total quantity of honey in the two on mixing these two vessels will be 2 by 4, that is 1 by 2, plus 3 by 4 into 3, which is nothing but 9 by 4. So overall quantity will be 9 plus 2, that is 11 by 4. So the amount of honey by mixing these two vessels will be 2 by 4 plus 9 by 4, which is equal to 11 by 4. So this is the amount of honey. Now similarly we will find out the amount of water. So in a first mixture 2 liter is drawn. In this 2 liter the amount of water is 1:3. So water amount will be 3 upon 3 plus 1, that is 3 by 4 of the 2 liter. And the amount of water in the second mixture, and the second mixture is of 3 liter. So from this 3 liter we have water in the ratio honey and water in the ratio 3:1. So the amount of water in the 3:1 will be 1 by 1 plus 3, that is 1 by 4. Fine. So this is the amount of water, which is nothing but 6 by 4 plus 3 by 4. So 6 plus 3 is 9 by 4. So this is the amount of water, which is 9 by 4, and the amount of honey is 11 by 4. So the ratio of honey and water in the mixture of these two vessels will be 11 by 4 is to 9 by 4, which is equal to 11 is to 9. So 11 is to 9 is the ratio of honey is to water in the another mixture. Fine. Now this is the one way of doing this problem. The other way is to solve this problem in terms of percentage. Let's say that the percentage of honey in the first mixture is 1 by 1 plus 3, that is 1 by 4 of the total vessel, that is 25%. So in the first mixture ratio of honey is to water is 1:3. It means the honey is 25% and the water is 75%. In the second mixture we have honey in 3 by 4 of 100, that is 75%. So in the second vessel we have honey as 75% and water as 25%. So if we mix those two mixtures, that is first mixture and the second mixture, we will get the another new mixture. So in this new mixture 2 liter will be from the first mixture, so 2 into 25% plus 3 liter will be from the second mixture, so 3 into 75% upon total will be 3 plus 2, that is total total quantity of the new mixture will be 5 liters. So 2 into 25 plus 3 into 75 divided by 5, and that will be equal to 275 by 5, and that is equal to 55%. So the percentage of honey in the new mixture is 55%. This is by the percentage approach. Initially which I have taught you is with the ratio approach. Fine. Anyway you will get the same answer. Similarly we will find out the amount of water in the new mixture. Let's say that the amount of honey in the new mixture is 55%, then the remaining will be water. So water will be 100 minus 55, which is nothing but 45%. So 55 is to 45 is nothing but 11 is to 9. So answer is same as there in both the approach. So the answer over here is 11 is to 9.